Hello everyone, welcome back to another lesson. Today is 6.3, the square root function and inequalities. The focus of this lesson is on graphing. Now when we do graphing, most of the time we resort to Desmos, or your graphing calculator if you have one. And that will ultimately be the case today. However, I'm going to take advantage of this time to review something we've already learned. Occasional review is not a bad thing. So we're going to talk about parent functions and transformations. We did a whole unit on this before, and it is going to apply today. So the parent function for today's lesson is f of x equals the square root of x. So the square root function. And I just realized that that was already written up here. I didn't probably need to write it down a second time. Oh well. So as far as graphing, you take the parent function in whichever form it may be, and you do things to it. You can shift the function up the graph. Well, let's use the word graph. You can shift the graph up or down, left or right. If you recall from geometry, those were called translations. You can reflect the graph over the x-axis or over the y-axis, and those are just called reflections. And you can dilate the graph, called dilations. Vertically, you can expand the graph by multiplying it by a number greater than 1, or compress it by multiplying it by a number between 0 and 1. Between 0 and 1 would be a decimal like 0.5, or a fraction like 3/4, a proper fraction. You can also do a horizontal expansion, again by multiplying, but this time it's inside the function instead of in front of the function. So inside the function by a number between 0 and 1 creates a horizontal expansion. Multiply inside the function by a number greater than 1 and you get a horizontal compression. So when I go through my examples, I'm going to talk about these aspects of it. But I am also going to use Desmos, which you are allowed to do as well. So I'm going to ask you to kind of bear with and try to get something out of the transformation review. But ultimately you can use Desmos. And then we're going to do some inequalities. Remember, inequalities are less than, greater than, less than or equal to, greater than or equal to. When you graph a function that is a less than inequality, that's going to have a dotted line or dotted graph with shading below the graph. Less than would be below. Greater than is above, but again a dotted line. When you have less than or equal to, you draw a solid line, but still shade below because of the less than part. So the equal to represents the idea of a solid line. Greater than or equal to, again, solid, shade above. So that's kind of everything you need to know, except for the shape of the parent function itself. So I'm going to do a little xy axis right here. The overall shape of the square root function, it starts at the origin and it sort of arcs off to the right. It does not go to the left, it merely goes to the right. Okay, as we go through this also with the graphs, we are going to talk about domain and range. Domain is simply the x values of the graph, and range is the y values of the graph. The software I normally use to make these lessons did not contain this topic, so I had to scan work from the textbook. So that's what this is, and it's 2 pages. It looks like a lot. You might say it is. It's actually 20 problems. When I do the when I do the evens, I better get that straight. When I do the evens, that's going to leave 10 odd problems left for you. So hopefully it won't find it, too overwhelming. And again, you're going to use Desmos for a lot of it. The answer keys are attached as usual. And yes, there are a couple word problems, and no, I don't think they're anything you're going to need to freak out or worry about. Okay, so let me start, and again, I can see myself messing this up, the evens. I'm going to highlight the evens so I don't hopefully get too off track in doing the wrong problems. Give me just a second to do that. Just a little visual reminder so that I don't mess up, because I mess up. Okay, so graph each function and state the domain and range of each function, starting with number 2. All right, so I am going to draw the parent function first on just a couple of these problems. You do not have to do this. I'm going to do it just as part of the teaching process. So y equals square root of x is the parent function. Again, it starts at the origin. It actually passes through the point 1, 1, and then gradually arcs out in this direction. Why does it go through 1, 1? Because if you look at y equals the square root of x, I'm sorry, I don't want to use y and x. I already wrote that over here. 1 is the square root of 1. So, of course, the point 1, 1 is on it. Also, the point 4, 2. 2 is the square root of 4. And actually, I drew it a little bit off. It should go through the point 9, 3 because 3 is the square root of 9. So if I was going to do a really good job, I would draw it like this. Now let's talk about the actual function that we're going to graph. That negative sign is going to flip it upside down, and this 3 is going to vertically compress it. When you vertically compress it, that kind of, when you push on it this way, it's going to make it sort of bunch up. So it's going to have more of a kind of a squished shape. But it's going to flip upside down also. So when I graph this on Desmos, I'm going to expect to see something kind of like that. It's not going to go through 1, 1 anymore, or 1, negative 1. It's been compressed. So, okay, let me erase some of this extra foolishness, get it out of the way, and I will pull up Desmos and show you how to type this in if you need to know how. Nope, that's the wrong thing. Oh, sorry, had an alarm set, didn't realize it. All right, bring this over here. Taking its time. So y equals square root of x. Again, there's the parent function, but we don't want that. We want y equals the negative square root of 3x. And as you can see, okay, my colors are inverted. It's funny that red and blue happen to pop up on the calculator, but I'm relatively close. So I'm going to get rid of this one. This is not part of the answer. I just wanted to sketch the parent function. And I think right around here my arrow gets a little wonky. So if I'm going to try to do a little bit better, let's see, it looks like 5, negative 4, roughly. I mean, 5, negative 3 point something is on the graph. Let me switch back to blue. So kind of like that. So a little more compressed. Now, what about the domain and range? So I'm going to use, let's see, I'll go underneath. D for domain, R for range. Domain is the x values of the graph. Well, this starts at 0, and it proceeds to the right forever, which is infinity. And that would have been smart to do that way. There you go, infinity. So the domain is x values greater than 0. Actually greater than or equal to 0, because it actually starts at 0 and it goes in the greater than direction forever. The range is the y values. Now the y values of this graph start at 0 and they go down forever, right? That arrow, even though it looks like it kind of levels off, it does keep going down forever. So in that case, the y is less than or equal to 0. 0 is the highest number, and it goes down forever, which is less than. All right, let me check number 2 on the answer key, and there we have it. Oh, wait, no, that's the wrong number 2. The wrong answer key, sorry. Right there, there we go. All right, they did the domain and range in this funny bracket situation that's called set notation. As long as you get that part of the answer correct, I'm fine with that. All right, let's look at number 4. So number 4, again, the parent function looks like this. Ours has been shifted. Now, it's underneath the bar, which means it's a horizontal shift. If it was outside the bar, that would make it a vertical shift. But this one's horizontal. Plus 3 is going to move this graph to the left 3 places. So my graph should look kind of like that. I'll erase the parent function. So using transformations, that's what I get. Let's use Desmos. Y equals the square root of x plus 3. And there you go. Yeah, I think that graph is as good as I could possibly have done. Now let's do the domain and range. Domain is x values, range is y values. Now, this graph starts at an x value of -3, and it goes in the x direction to positive infinity. So that means x is going to be greater than or equal to 3. As far as the range, which is the y values, this graph starts at 0 in terms of the y-axis, right? And then it goes up forever. So that would be y is greater than or equal to 0. It starts at 0 and then it goes upwards forever. So that's what I plan or hope to see on the answer key for number 4. Graph looks good, domain and range. All right, so you get an idea how this is. Yeah, if you're good, you can probably get to work, except I haven't done the inequalities yet, so you might want to wait till I cover an inequality. You might want to fast forward to the end to see me do the word problem possibly as well. All right, let's look at number 6. So this one I know is going to be left 4 units and down 2 units. So I start at the origin. I go left 4, down 2, erase those dots. I'm going to pass through this point and go kind of like that. So if I were not using a calculator, that's how I would do this. Using a graphing calculator obviously takes all the thought out of it. Not necessarily a good thing, but not a bad thing either. Just depends on your goals. All right. And it looks like I should have made it go through the origin. Not a big deal. That's a good enough graph. Let's do the domain and the range. Domain, again, just a word for x values. This starts at the x value -4, and it goes to the right forever. So x is greater than or equal to -4. The range starts, the y values start at -2 and goes up forever. So that's y is greater than or equal to -2. Let me get rid of some of those extra little marks that I drew and check number 6. And everything looks reasonably good. I say reasonably good because you're never going to draw a perfect graph unless you're copying and pasting. But yeah, good. Number 8. Now number 8 is our first inequality. If we were doing this without a calculator, there'd be several things that go into it. First of all, our parent function, which is square root of x, has a +1, which is going to move it to the left 1. There is an equal sign involved in the inequality, so I do draw a solid line. And the fact that there is a greater than in this problem means that I need to shade above. So like from here over, I shade above. So my graph should look like that. Now I don't think there's no instructions on domain and range for this one. You don't need to worry about that. And there's the picture. No dotted line here. I like to do that. You don't have to do that. But notice there is no shading over here because there is no graph over here to shade above. So you're only shading above the graph itself. All right, let's move on. For the rest, I'm just going to do Desmos because I'm guessing that's how you're going to do it. I know this one is going to be shifted right 1 and upside down. I can almost just not help myself from talking about that. But if you're using Desmos, there you go. So right here, and it sort of goes like this. The domain, the x values, well, they appear to start at +1 and go to infinity. So x is greater than or equal to 1. For the range, it appears to start at 0 and it goes downward forever. This does continue downward in the downward direction forever. Wow, that makes no sense what I just drew there. Anyway, so that would mean that the y values are less than or equal to 0. All right, let's check number 2 on the second. Yeah, so that's the right graph, and that is the right domain and range. Yeah, always good to use the correct answer key. Number 4 is going to be shifted right and compressed. Let's get a good look at how Desmos does it. So 3x minus 4. So what the heck? All right, so where does it start on the x-axis? 1.333. Do you know what that is? It's good to have some basic running knowledge about decimals and fractions. 1.333 repeating is the same thing as 1 and 1/3. So on Desmos I have to type 1 plus 1/3, and you see you get that. Now I know that there's only 3 3s there. It doesn't go on forever, but that's a, what do you call it? It gets rounded off. Desmos would round that off. So why does that matter? Why do I want to know that this point right here is 1 and 1/3? Well, it's for the domain. The domain is going to be x is greater than or equal to 1 and 1/3. If you put what you see on the calculator, 1.333, and you go down and check it, it's not exactly going to be right because, again, this is a rounded off value. So it would be better to know that that is 1 and 1/3. You might say, well, what if I didn't know that? Give me just a second, I'll explain. Let's go ahead and do the range real quick. So the y values start at 0 and the graph goes up forever. Y is greater than or equal to 0. So what you could have done is taken the 3x minus 4 equal to 0, square root, square both sides, add 4, 3x equals 4, divide by 3, x equals 4/3. 4/3 is the same thing as 1 and 1/3. There's the whole mixed number versus improper fraction thing. In fact, the answer key may actually say 4/3. I don't know. Let's go down and check. Yep, they used the 4/3. So answer graph looks pretty good. Get rid of this. You don't really need that. And I guess I'll get rid of that. There, now mine matches the actual answer key. Okay, number 6. Y equals 1 minus square root 2x plus 3. All right, look at that. Wow. So first of all, what is that point? Negative 1.5 comma 1. Right about there. And what's that point? 0.7-ish, so kind of like so. There's my graph. The domain, the x values. So the x coordinate of that endpoint is negative 1.5. Sorry, so I'm going to put x is greater than or equal to negative 1.5. Now what's negative 1.5? That's the same thing as negative 1 and a half, or you could make it the same thing as negative 3/2. Negative 1 1/2 and negative 3/2 is the same thing. So I'm guessing the answer key, since the last one did an improper fraction, they're probably going to use this one, which has an improper fraction. The range, well, the y values start at positive 1 and go downward forever, so y is less than or equal to positive 1. All right, let's check number 6 and see which answer is the right answer. Yeah, they use the negative 3/2, and I believe that is supposed to be a negative sign. It looks like it kind of touches the fraction bar, but there we go. Good enough. Another inequality, number 8. Oop, don't do the answer key right here. So y is less than. Now, you know what? I'm going to do just a less than real quick to show you, because it's been a while since we've done these. So if it was just less than, you see how there's a dotted line there? Make sure you would draw that on your paper if you ever have these dotted lines. This one is a less than or equal to, so it is going to be a solid line. Let's see, what is that point right there? 5, 3. So 1, 2, 3, 4, 5, 3. Solid line like this, and then shade below it like that. And again, on inequalities, there is no domain and range that you have to talk about. Oops, so there's my graph. But you see, like on number 9, how it's got a dotted line. You do need to do that. All right, number 10, a word problem. The velocity of a roller coaster as it moves downhill is this equation, where v sub 0 is the initial velocity and h is the vertical drop in feet. if v equals 70, so that's not v sub 0, that's not this variable, that's just v, which means this one. And v sub 0 is 8, so that's this one. Find the feet, find h. Find h. Well, I did not give myself a lot of room to work here, did I? Crud. And I didn't give you a lot of room either. So work this out on a piece of scrap paper or something if you need to. Basically, I need to take, get real crazy with the highlighter. I need to take this formula, and I'm going to plug this number in right there, and let me color code this. I'm going to plug this number in right there. So 70 equals the square root of 8 squared plus 64h. Now, find h. So I need to manipulate this equation so that I can solve for h. Well, the first thing I'm going to do is rewrite it like this. 70 equals the square root. What is 8 squared? 8 squared is just 64. So 64 plus 64h. Now if I want to solve this, I'm going to need to square both sides because squaring cancels out a square root. I get 70 squared, good grief, 70 squared, 4,900 equals 64 plus 64h. And I'm getting a little confusing here. This should be an arrow. So I got like step 1, arrow, step 2, arrow, step 3. I'm going to draw an arrow up like this to give myself a little more room. So 4,900 equals 64 plus 64h. Yeah, if I was using that software I always use, I could have increased the space between here. But all right, whatever. Minus 64 on both sides. 4,900 minus 64 is 4836 equals 64h. Divide both sides by 64. So 4836 divided by 64. H equals 75.5625 feet. So that roller coaster is just a little bit over 75 feet tall. Let me check the answer key and see if I did that right. And they rounded off. They used about 75.6 feet. Good enough. There you go. So yes, it was a word problem, but all you had to do is take the numbers that are in the word problem and plug them into the equation that was given in the word problem, and then just do some basic algebra steps to work it out. So number 11 should be pretty much the same thing. If you think you've got enough room in here to work it out, go for it. If you need to just do your steps in a different sheet of paper, I understand. All right, I'm going to stop there. If you have any questions at all, please contact me. Remember, do the odds, and then just, good luck, and talk to you later.